Okay, traffic sim. So, and I kind of referenced it, but can Vibes plan traffic? We'll see. But I'm going to show you how math can plan traffic. Welcome back. Thanks for joining me here today. We're going to try to do something a little different. So I've been getting some requests, seeing if I could give a little more background on how the simulations work, how the models work, how I'm building this stuff, etc. So I wanted to really dive in today and give a little behind the scenes tour of my setup, what I'm building, how I'm building it, how I'm learning things as I go along, and a little glimpse at the simulation that's going to be in this upcoming episode. Yeah, so hope you enjoy. Let me know what you think. All right, here we go. Traffic sim. So I had made a bet against Thomas that Vibes can't plan traffic. When I think of traffic, I think it's very much a numbers game. So on many different scales too. You can think of just like at the city scale, we have a very big network and there's a lot of different people involved in a lot of different areas. So the complexity of understanding and analyzing the whole systems becomes a lot, and you need numbers to kind of rise up some of these trends and statistics, like where are all the people coming from, where are all they going to, etc., etc. And the other area numbers become very important is at the small scale. So we have to, at the end of the day, come up with a precise algorithm, for example, to operate traffic lights, right? And this is saying like the east-west route is going to get 30-second green, and then it will rotate to the next car. Obviously, you guys have probably all experienced these, and a lot of these times, these algorithms aren't that great. Like they're tuned for the wrong time of day, etc. So as we kind of keep digging into traffic topics, I'm going to build some demonstrations of different types of algorithms you can use to run these, how you can tune them based on arrival rates, stuff like that. And at the end of the day, a lot of these things need statistics. I've never been part of like a traffic planning department, so this area is very intriguing to me, but I'm curious on what sort of data the city has to do these planning for these algorithms. So those are the two areas where I think numbers kind of end up playing a big role, and kind of our modeling of them is very important. So both at the large macroscopic system scale and then at the microscopic scale for operating various equipment on the grid, such as traffic lights. And here's a curious thing, at the end of the day, I made this bet, and then I'm building this engine to referee it. I've kind of got competing objectives or misaligned incentives, to say the least. So maybe we can touch on that topic as we go through this. But stay tuned. Hopefully I tried to make this as fair as I could, possibly doing it with my own bias intertwined. So I tried to make it fair. I give 4 options for upgrades that Thomas can do. And he has to choose the best. So 1 and 4, and with an engine that may or may not represent reality, it seems a little unfair. So, my goal was to make the winner a clear winner. So like the winner improves traffic, or reduces congestion by like 20%. And the losers are like 0 or 1 or 2 or minus 5%. So, by my engine standards, it's a clear winner. I didn't make them try to decipher a few percentage points, because that's obviously the engine issue. So I was like, okay, I'm going to create a traffic simulation. I'm going to create a baseline, and then I'm going to create multiple upgrade scenarios, and he has to choose the best one. So that was the bet I proposed. So, and I got my initial prompt that I started this project with. So if you think about these LLMs, they have like 200K tokens. And if you think about that in the scale of a traffic sim that's distributed, like with pretty complex piece of software that we're going to try to tackle here, like it's not going to happen in one context window. It's going to be more like 200 or maybe 50 to 200 or something, would be my guess off the bat. So I'm like, before you start burning sessions, like what you need to do is build up a solid knowledge base, a solid like document structure and repo structure, such that when you start fresh, the agents can ground themselves extremely quick. So a lot of progressive disclosure type strategies, and such that and a lot of decisions such that they're kind of the agent's first instincts. So an agent's first instinct might be to look at README and read that. You can try to enforce these things, but trying to just leverage the conventions that people have built over the years, progressive disclosure, and building documentation first. Such that when there's disputes, we go to the documentation, and when that is different than what we want to do, we escalate to kind of myself or even reviewers at times to kind of make decisions one way or the other. So this is very much important if you're going to have any sort of project that's going to last, I'd say, more than 5 sessions. If you think about your project, what you're trying to accomplish, if you can't do it in 5 200K sessions, start documentation first. Okay. I learned the theory after the repo. I think that's kind of true and kind of not. So PDEs aren't necessary for the traffic simulation. PDEs, so modeling traffic as waves, it's more kind of like a technique that could look at simulation data and be like, does this match with how the waves in the real world work, right? So it's my weakest area, as I pointed out. So it's one that I want to learn, but it's one that I wanted to learn because it's kind of this cool math topic. It's this cool angle at understanding traffic, and it's got some very cool on how the information wave travels backwards, and the concept of a phantom jam where it's traffic starts out of nowhere, and I saw this video of this lab that made people drive in circles, and they saw these waves form. It's everyone try to drive the same speed and these waves just naturally form. It's just kind of a way people drive. Maybe it's different once you have autonomous cars and you don't have people with kind of reaction times and stuff, or kind of more variability and stuff. But one of the first things I did too was when I started the repo, I started building the knowledge base on purpose right away. Knowledge base is the memory, like I said. So this is one of the biggest things that I propose now when you're working on somewhat bigger projects. This is greenfield too, so it's a little easier, but honestly you can scaffold these knowledge bases quite easily too with LLMs. So it's just almost any sort of project of any size should have one of these, even small ones. I see little downside besides that they can drift, but you can enforce that via CI/CD and best practices. So I see little reason not have this, and it's it's good for the agents to understand, but it's just as good for me to understand. So this is how I ground myself when we were building it. It would build the ADRs and then I would go read them. I very much believe that to build a bigger project that's scalable and doesn't just erode into tech debt, I need to understand it myself too. I have to be an active participant in it. Some could say driving it and stuff, but I very much have to understand it, or I think it just kind of ends up waffling. And, I think even with making documentation, LLMs are just so verbose, and they just are so any one line is just not so serious to them, where I can find some sort of kernel of truth in my head and I'm like, this is kind of the way we're going, and kind of like use that as some sort of anchor guiding post, where it just doesn't seem like they quite have that there. Such that, like all of these loops or goals, like I find they're very good at burning tokens, less good at building like software that accomplishes goals I have. I used it a few times, like these goal functions, to kind of make it so it can loop and stuff. But at the end of the day, I think, it's like it just burns more tokens and doesn't end up in a better spot than me just waiting till I can sit at my computer, focus, and spend time to build the software that I want to build. Like I just end up in a better space. It's more scalable. It actually does reasonable things. Like many times, like it just like I set the goal and overnight it ended up like basically in the same issue, and then my next session I was able to tackle the issue I had. So it just like was burning tokens overnight for no reason, and then I solved the problem by working with it to achieve a goal. All right, 5. So this is adding the review gate. So basically a git hook, and it refuses a commit unless the reviewers are happy. So here's my line. So you can see often I have these ideas of how software is done, but I don't often have giant structure in my coding practices. I'm often typing like lines like this. I don't have like a 3-page prompt I always use for review structure. I often kind of tailor it to the project I'm working on. So I'm just like, okay, I want to try out Soul. That was one of my goals, is get GPT 5.6 involved. I had used Fable on my last project. I was very focused on using Kimi K3 on this project. I honestly love the model. I think it's great, and it's like a lot cheaper than Fable. And I think it's better than Opus 5 too. But regardless, that was the main coder. And then I wanted to get these two as reviewers. And I think they did a great job. They were constantly catching issues. I think the problem is determining which issues matter and which don't, which it's just like, I think it's this sliding scale. As I get deeper into the project, the smaller issues matter a lot more. But I don't think I had that nuance really in this. I think I added it and it was very rigid, but it just ended up costing more tokens. But I don't think, maybe it made the progress slow too a bit, but at the end of the day I got to where I needed to, so it was fine. Yeah, okay, so July 26th was when I finally started to get the traffic simulating Chicago. So, and I'm not going to give away about the Chicago bit, but I ended up choosing Chicago to work on for this simulation. So I was like, okay, I can simulate all of inner metropolis Chicago traffic. This will be no problem. I'm just going to import it all from OSM and turn it on and go. And of course, like this started like, I think it's been 5 days now of trying to fix all these random issues. So as example, like how do traffic lights work? How come gridlock is so easy to form? Why are the freeways lightly loaded and the inner loop is heavily loaded? How do we scale demand profiles? Like how do we build arrival rates on these freeways? I have a lot of ideas on how we could do this, but I only had so much time to implement them, so I was using very crude methods. But like as example, I have a building data set or census, and we can estimate number of people that live in these different regions, and we use that to build the demand profile because 25% of people work downtown. A lot of cool stuff like that we can build. So I have this very cool like demand profile input tool, but to power this, you need all sorts of data. And, it's like, as the simulation got more and more complex, the needs for it became more and more complex. In actuality, like traffic across the whole of Chicago, I don't know how many people live there. This should be one of my things that I should have got in the early research, but, it's probably millions of people. I don't know how many cars are on the road, but like, I think the peak that I've gotten for my traffic simulation, and we'll see a picture of it. Maybe I'll do a quick picture of it in a little bit, but I think I only got to a peak of like 6,000 to 7,000 vehicles on the road being simulated, and my simulation was running at 10 hertz, so 10 ticks a second, which is a decent scale. It ends up congesting decent parts of Chicago, but I think it drastically underestimates like the number of cars on the road. So like I think that's this, if I had a metric for trying to get where I want my simulation to be, it would be like, can I put as many cars on the road as there are in reality for kind of morning or afternoon rush hour? That's kind of like my big objective. I didn't hit it. I want to get there, but I'm not going to get there for this episode. So yeah, that's this headline. Chicago broke it. So I went and got it imported, had a bunch of issues, and I it's kind of simulated, not to the scale I want, but gridlock, total gridlock, collisions, so cars inside of other cars, zero driving logic. I don't know. There's a variety of issues that I've been slowly tackling over the 5 days. And I think this is the project, like the initial build, the screen field, it's like, oh, I can tackle anything. And then as you start to solve the real problem you're after, you hit all of the issues that make the problem hard. So like this last 5 days, this is like, okay, this is why this problem's hard. Sure, I can go build this system that looks great at first, but once you start solving the hard problems, it takes real work with thought. And like, I'm still to the point where, it's like I'm building something and then I leave and I'll think about it, or like on a walk, an idea will pop in my head and like, oh, that's the issue. Or, so it still feels like, the LLMs are, they're helping, they're making me more productive. It hasn't really felt like it's changed that much. It still feels like I'm still building things just with different tools. Some of this, actually, maybe like 10 to 30% of the issues might have been because I decided on a distributed system versus a monolith engine. Part of this was me trying to create an architecture that was slightly more complicated. And one of the benefits that I want to unlock is this horizontally scaling. So now that it's distributed, it's easier to build micro regions. You can still do this in monolith structure, but it'll be easier because we already have some natural interfaces. But we can better decouple this such that, so we have our inner loop, this first version that I'm making. I hope to get like 20 to 30,000 cars in this grid. I think that's roughly the scale we can tackle at 10 hertz. But then you can imagine doing the neighbors. So I might have like 4 or 5 neighbors. Each of those would run their own simulation. So they'd have their own engine running it. And then we set up interface, so people going from one to other, maybe some sort of overlap, some sort of arbiter that kind of helps transition these things. But then you can start to see this macro structure that's now interacting with different grids, and these grids have these microstructures. That's all of this car simulation. And then you can even see it on one more fine scale. So say you zoom into a road. So my simulation uses intense and arbitrated speeds and single lanes. But you could imagine zooming into a road and giving them like more XY freedom or ability to crash. And these could flow up and down this like Z scale of precision and stuff. So I think this distributed system can have, some beautiful scaling both vertically, to micro to macroscopic, and then horizontally from grid to grid. So I think there's some really cool structure that I hope to explore in future versions. And finally, this last day, I started to try to bring more real world into the engine. So this will be a process over time. But to do this, I want to try to be able to better analyze traffic videos. So I'm starting to get videos of like traffic on freeways, traffic at traffic lights, and I want to be able to measure arrival rates, like traffic algorithms, so understand when green lights and red lights are going, timings, and etc. On the freeways, I want to see these information waves according to LWR and measure them for myself. So I started to create some better video analysis so that we can go from videos of traffic into kind of concrete data and stuff. So hopefully I'll have some videos like that to show you guys soon. All right, here is the timeline. I started by trying to understand the traffic space. So I don't have a whole lot of background in this. I'm an industrial engineer by trade, industrial and systems engineering. So ISYE, a great engineering discipline. And it's got a very broad spectrum of people that go into the world. So there's like human factors. So people understanding workplace environments and how to make them safe and good for people, etc. There's kind of more industrial processes, so trying to streamline industrial facilities, value chain operations, etc. And then there's also a discipline called operations research, which is a very big mathematical basis, doing a lot of topics like probability statistics, a lot of optimization work, etc. So this has a lot of overlap with computer science, mathematics, and then in the application of these fields, it's in businesses, healthcare, all sorts of things. So there's a whole lot of applicability to kind of all over the place. So you get to work on different topics from like traffic to healthcare, all sorts of fun problems to solve. My particular background's kind of more in applying it to energy systems. So maybe that will be a future topic. But anyways, in school, so I went to University of Wisconsin-Madison. I built up this big toolbox of operational research techniques, so mathematical modeling, simulation, probability theory, to solve problems in these different fields. A lot of ISYE focuses on coming at it from a systems perspective. And, I have talked to Thomas some about this, and he also likes thinking at a systems perspective. So, we have quite a few things in line too, even though we tackle things in kind of quite a bit different ways. But anyways, I have this big toolbox, and then I try to apply it to different fields. And how I go about doing that is when I come to a field that I don't understand or don't know a whole lot, the initial part is trying to learn about it. I often do a pretty abbreviated initial learning phase, and trying to start dig in right away. I found that, I learn best by doing things. So I tried to show this timeline roughly of how I went about this. So learn the domain. So I was trying to learn about traffic. In particular, I wanted to build some sort of traffic simulation that could replicate traffic patterns in different environments. So I was thinking about replicating things, stoplights, kind of like merging on-ramps, etc. And, I like to try to think big. So at the end of the day, I was hoping to be able to simulate an entire city, as example, like Minneapolis or Denver. So you can imagine everyone coming in. So we have all these huge arrival rates on these highways coming into the city, and then all these people are trying to get to different places in the city, and trying to model these kind of traffic problems. So like people are coming in at such a rate, they have different destinations, and then once they get into the system, traffic will flow. So there's going to be routing algorithms for each of the vehicles. So any one given car is trying to get to some destination. And, just a quick preview, I had a static routing algorithm, and that creates a lot of deadlock. And what's, very common these days is more of these adaptive routing algorithms. We all have Google Maps. It sees traffic, and then it will adapt and route around gridlocks, etc. So, I ended up hitting that in my simulation pretty early on and tried to fix it. So this whole beginning part was trying to learn what people are doing in the field. I do like kind of like learning and hitting the wall. I think that's, like failing at things is a very big part of my process. But at the same time, like if you just did that, it would be very slow to get up to speed on any one given topic. So, I often do start with an initial review where I understand what people have already done, how they tackle these problems, what you could expect from like a state-of-the-art type algorithm or state-of-the-art type simulation, or what people are selling to industry, which I don't even know if I got that far, but that's just an example of things that I might look at to understand how much can I expect out of what I'm building here? How aggressive should I try to be in building something? What we'll talk about in a little bit is, now that we have like AI and LLMs that can code and kind of go through, like just do more research and code faster, review faster. I'm a lot more aggressive now on what I think I can tackle. So I'm trying to tackle software engineering problems that I wouldn't have even tried, like maybe this traffic sim, like I could contemplate doing this in a year, but it'd be such a slog. I would never really attempt something that aggressive. So I would have tried to come up with some shortcuts to kind of make what I'm trying to do a little more tractable, such that I could achieve something realistic in like 2 to 3 months or something. That was about as much as my dedication would be willing to go. But now, you can kind of shoot for the moon in a lot of ways and hope to get realistic results in 2 to 4 weeks if you're working towards like something that I'd consider like a decent problem to tackle. So it's not like one shot prompts, but it's also not something that you're going to like be like, is this achievable? I don't think, even if I spent all this time and resources, like I probably won't get there in 6 months to a year. Like I don't really want to go through that slog. I want to kind of keep working towards things that are achievable so that I can kind of feel progress, adapt, etc. So there's that learning phase. And you see the rate happen pretty early, like I like to kind of dig in, and you'll see that as I go through this, the rate is actually like building up internal knowledge in the code base. So like it doesn't really, so I guess it does say this. So it is knowledge base. So throughout this whole time, I'm maintaining like a decently technical record of kind of what the competitors are, summarizations of research, summarizations of other simulations that are open source, etc. So I'm trying to distill all that into a knowledge base. And then also it's talking about decision records. So keeping track of decisions that I've made. And then, like in these agent files saying like, we need to stick to these decisions. If we deviate, we're going to have to have a discussion about it. And this is to stop it from flapping. I think, maybe 4 to 6 months ago, this was like a big issue, but people have generally solved this at this point. And these like knowledge bases are one solid way to kind of solve these problems, where it's like kind of keeps building new functions to achieve the same thing. Whereas if you have a solid knowledge base, you have solid structure in your code base, and you're kind of enforcing stylistic rules on your coding practices, you have a lot less of this flapping, a lot less of this duplicate code. It does happen. It's just these things are inherently random and probabilistic. So you can only fix so much of it. And then you can see I started building this thing on the 15th. It's been roughly 15 days, 2 weeks. I would say we've got a passable referee. It certainly has plenty of errors. We'll see how much grief I get from Thomas because, when I look at it, I see things that aren't realistic. But at the end of the day, like I have to make something that we can go and shoot and achieve some sort of goal. I can't work on this forever. I think this is a good stopping point where it provides enough realism that we can answer some interesting questions. And then if we get back to traffic again, this is going to be a great building point where like now instead of all this scaffolding work, 2 weeks worth of work on from this point, like we can get like enhanced realism at the city scale that I think would be so cool. So I think we're getting close. Okay, and then roughly 5 to 6 days into this, I started adding the review gates. So this is a good thing. I don't like to do it super early just because on these greenfield projects, I would say it's not like stabilized. The code base hasn't really stabilized. I'm still contemplating significant refactors or rebuilds depending on how like initial prototyping goes and stuff, on whether like I'm getting like slow feedback loops in certain avenues that I wasn't expecting. Like I might deviate my path. Like the big decision I had on this one was I wanted to make this as like a distributed system simulation. So here's kind of the rough idea, and I'll talk more in depth about this later, is I could have this whole engine inside, one process. So like say it's Go or Rust or just TypeScript or something. And the engine tick, the driver's decisions, the traffic routing algorithm, all of this kind of happens inside engine. And it's all contained, and we run it at like 1 hertz and stuff. And it's very simplistic and it's very nice. Like it honestly is a way more simple than I went. I like to try to shoot a little farther than I need to learn more. So that I think, and I think people are finally coming back to monolith scale a lot better than people expect. And building distributed systems is like often just unnecessary, because if I would build like a tight, highly optimized engine and controllers in process, like I could scale that as big as I want and likely not even ever hit bottlenecks, right? Where once you start adding distributed system and you have kind of all this async operations, you add all of this like reliability issues. So what happens if you don't hear back from someone? You have all of this overhead. So now it's not just like reading things in memory at different locations. We're passing them back and forth over some sort of wire like HTTP or NATs, which is what I chose for this distributed system. It's kind of my go-to. So that was kind of one of these decisions. So like if I wouldn't have made enough progress that I was hoping by like the 18th to 20th, I probably would have deviated. And that's where it's just like, okay, if I'm doing these review cycles, which are often slow and a little painful at times, just because the LLMs are also good at catching bugs that might just be edge cases that never matter. And what happens once you start tackling all these edge cases, you're just like building up all this code base, which makes it harder to kind of change things in the future. It's like tech debt, So anyways, I don't like to add those too early. At some point I was like, okay, this is pretty solid. Like I'm seeing things in the simulation engine I would have hoped for at this point. I don't want like things to go like backwards from this point, but I think also bigger is just like I don't want like hidden failures or silent failures or things that like I'm not even like really thinking about to kind of subtly corrode the foundation of this engine. So at some point, we want to start putting more thought into each change set that we're making to make sure we're kind of going in the right direction. So it's this conscious effort to kind of start things to move slower. And you can see that was about 1/3 of the way through I started this review process, which made things slower, but in general, I think a higher quality of things, which, good and bad. And it just slows things down in general, but for good reasons. It's just this trade-off. And I think the trade-off isn't whether you do it, it's where along this curve you start doing it. And then, about a few days ago, I was starting to get simulations of Chicago that were functioning without like straight deadlocks or like just like weird things where the highways don't have any cars or stuff. And we've got a lot of cool features at this point. It's like I think I built a big system. It's probably too complicated for what we have here, so it'll take a while to unpack all of the functionality that this thing could deliver over time. But I think it was enough to kind of get to where we needed to for the episode. But it also is just such a cool, solid base for kind of future projects in this traffic area. So that's when I started kind of getting videos. And I think up here, I started relearning a few things. Like at one point I went and tried to understand like other state-of-the-art simulations, some open source ones. I didn't look at the commercial space. I probably should have. That's often where like you kind of understand what you should be shooting for and what you can hope to tackle. But there's a good open source one, Sumo. I think it's SUMO. But then here you also see LWR and PDEs. So I was trying to learn some math along the way too. So there's a pretty cool theory, LWR, which is modeling traffic as waves and becomes partial differential equations. So as part of this podcast, I'm trying to learn more about math along the way and become a representative of math. So, I practice math a lot through my years. I have a fondness for it. I learned a lot in college. I had great advisors. Jeff Lindroth, he taught me so much at Madison, and I wanted to try to kind of keep that sharp or kind of keep learning. I like learning. So PDEs are one of my weaker areas of math, I think. So I was trying to learn more about the LWR, and I hope to do an episode on that coming up. So more to come on that, but these were kind of some of the learnings as a little foreshadowing for some of the content we're going to do over time. And this is just kind of another thing on the timeline, and you can see how many commits per day. Roughly this looks like a work week. This looks like I was starting, so likely there's probably more code here. It just wasn't committing as frequently. Whereas here I started the review cycles. So as basically I can't commit unless I go through a review cycle where I use Fable and GPT Soul as a reviewer. Once we get to the point where we're just like, you guys are ridiculous, like why does this edge case matter? Like this is a silly project with my friend, like you need to relax, versus like, okay, this really could haunt us and it might be under the radar and cause like confusing results in the future. So it's trying to hit that balance. I think the reviewers were a little overzealous or like the commit process was like under aggressive in committing. This is like very early in a project. Like you shouldn't be fixing crazy edge cases at that point. It's just adding more code that makes it harder to make changes. In general, I think, I think right here I could have started being more aggressive and I would have had a faster week here. Okay, so words I typed. So apparently I typed 7,500 words, 293 prompts. That sounds about right. I'm normally pretty terse in my instruction sets. So I'm not like typing out paragraphs. I sometimes like type a short blurb to get a paragraph from an LLM that I'll then use to further some agenda. I'm normally pretty terse. So 7,500 words, it doesn't seem like much, but I guess, that's potentially right. Output tokens, 16.8 million, 2,200 tokens per word typed. So basically I had 7,500 input tokens. It also had a bunch of input tokens from like reading my files and stuff. Then a bunch of cache reads for continuing sessions. But at the end of the day, these ended up producing 2,200 tokens of output, tokens roughly a word. I'd be curious on like the lines of code of my code base, but I saved some stats for future things. But 45% of output was review. So, I said these reviews were pretty brutal. It's not clear if like I used Fable to code this, if there would have been so much review. I found in general, like even the good models like Fable, Soul, they still have issues and review catches it. But potentially there's slightly more issues using Kimi K3. It reminds me of the olden day with like Opus 4.5, Opus 4.6, where, it definitely feels like it understands what I'm trying to do. I'd say it might be a little slower than Opus and Fable, just like in like actual tokens being created, or maybe it just generates more file. It just seems a tad slower. I'm talking like 5 to 15%, not a ton. So this is actually not, this is reviews run per day. So at some point I hit like a Fable limit, which you see I subbed in just Kimi again for another reviewer. 58 reviews, 50, 159. So as example, it's a single commit, and it would take 5 to 10 reviews to get it in, and then have that multiplied by 5 commits. That's 25 reviews for a commit. And each commit actually had 2 reviewers, so that's 50 reviews. So this might be like 5 or 6 commits at the end of the day. Did I have a commit per day? Oh, I mean, some of these are a lot of commits too. And then I think at some point I was like, okay, we need to be more lenient with the reviews. Kimi the Builder, 5.6 million tokens of output, 10 sessions. Opus 5, I ended up switching to Opus 5. It recently came out, so I wanted to test it. I think it did okay. I don't think it was better than Kimi K3. I've actually read some about it having higher hallucination rate. I do think it was like kind of sloppy at times. So, I think it's a little bench maxed, if that's the right word. But I think it also did produce some good code. I mean, like I did use it for a significant amount of time, and but I did have issues that I ran into several times where I'm like, what are you doing? Like, because I set a goal and it just completely wasted tokens for like 12 hours. That's dumb. I was trying to like solve some of these Chicago issues, like gridlock as example, and then I'd just come in and solve it in like a 2-hour session with some like back and forth. But like 12 hours of this, and it could even use Soul and Fable as like input, but it just struggled. Review loop, 45 commits, 289 reviewers. And the 2 reviewers rarely overlap. It's so funny. It's like, and I think that's these LLMs. They love to say things, and they're actually good at saying accurate things. So they almost always will have good feedback. Whether you should follow these reviews is a question. It's like, I think it increases tech debt and it moves slower. And a lot of them are just crazy edge cases. Like, this is a fun project. This is not some crazy production like healthcare PIIA project, but yeah, it's good practice and good learning. So overall, very happy with Kimi K3. It's my new go-to model. So I think it's great. Fable, I also think it's good. I just think it's very expensive for what it is. I'm not sure I think they're probably making good profit on their API cost. Their subscription is noticeably like less value. Like, I hit limits way more often than I used to. Fable also does have more usage, so take it with a grain of salt. Opus, I do feel like I got a lot of usage, but it wasn't as effective as Kimi K3. And I think Kimi K3 is still less expensive than Opus. And I think it's just as effective. I think it's like Fable level. I've seen some benchmarks that people have made, like these visual ones where they're making 3D worlds and stuff. So Fable, I think, has a leg. Like, it's slightly more frontier in a lot of ways, but I'm not building like frontier application. This is a traffic simulation. This doesn't need like the latest and greatest. So I think Kimi K3 meets my needs and is cheaper. I was able to accomplish a ton with like the $100 subscription to Kimi K3. One quick chat on should it be distributed or not. So early on, I envisioned the ability for these controllers to be interchangeable. So you can imagine we have driver controllers, and they're responsible for saying speed up, slow down, take a left, take a right. How should I route? With the routing algorithm, slightly different, but at the end of the day, it has to choose a route. They could choose a route among these things. So I have this driver controller, and I want it to be interchangeable. So you could imagine this going iterating, so a V1, V2. You could imagine an LLM controlling one. So now we have all these cars. I have a driver controller that does it. It generally works in batches of 10,000 cars. So I have one controller that operates 10,000 cars, sends like, I intend to speed up, I intend to slow down, etc. But you can imagine giving an LLM control of some of these, and having them control this loop, depending on some of this input lag and stuff. But I was like, okay, I want to make this simulation so that I can have like DeepSeek Flash and Fable and all these different models on the grid and, see if they operate differently, in some ways, see if they can kind of drive around my traffic simulation. And then the other thing I want people to be able to jump into a car and drive it themselves. So you can imagine clicking on the car and taking control of it, and then changing like your speed or kind of like stopping your car. So traffic builds up behind you and then going forward. So this was one of my big controls, and this basically ruled out an in-engine controller, less the ability to create an API. I think that's what Sumo does. They have some hooks and API that allows you to kind of manually override game controllers. My design's a little different where that things are distributed. So instead of responding to a message with my normal drive controller that I build, we can make new drive controllers that's just like taking input from a human or an LLM. So I thought that was kind of a fun thing. So like with these distributed systems, it's a lot about these seams and interfaces, which makes it really hard. But you get a lot of good things too. So since it's distributed, we have all these interfaces and APIs and schemas for kind of how things operate. And we have this kind of log that's naturally built through operation, and we can just listen to it and record it, write it to a file, and then replay it. We have a little kind of syntax on top of it, so the ability to seek and kind of replay it like a VCR for young folks. Okay, swap a controller, replay. And I think this last one, this could be a con, but I like to think of message limits as a pro. So I think this is such a true fact. Like message limits are a pro. As example, if I sent the entire game state as a message, the thing won't work. Like Nats has a 4 megabyte limit. You probably could adjust this, but honestly, 4 megabytes is too big. The limit should be 1 megabyte. I see no reason it should be 4 megabytes. And this enforces a good design because there's no reason we should be sending like jumbo JSON around all the time for game state. Like we can have a better design that's more cohesive and solves our need. We just have to sometimes think a little harder and stuff. So this, there's probably 2 or 3 times I hit this. And every time I'm like, see, I knew I knew there was some like dirty laundry underneath the things. And this goes to some of my philosophy when you're building these things, these kind of LLM-led code bases, is you need some way to kind of be able to see slices of how your system's operating. So either making demos or enforcing weird limits like this, because you can't cover up hard constraints. So this thing just broke if I started sending a payload that's over 4 megabytes. And it was just like randomly sending game state to all these different things for no reason, versus like the game designer can track things that it cares about or something. There's a lot more kind of elegant ways to tackle these things that will scale into the future. So sure enough, it caught like several things that were just dumb. And the only way you can uncover those is creating slices or ways to kind of exacerbate issues that you might expect to exist via demos. And then this demo blows up and you're like, see, you need to fix this and do it right. Like you're not doing good practices here. So that's kind of this philosophy that I've leaned on as I've done more of these LLM first code bases. There's a whole bunch of extra overhead for distributed systems. We need to know if things are alive. We need to know who's in control of what. What happens if you disconnect? Like once I took the driver out of the engine, it created all these complexities that we had to overcome. Because I didn't even have a fallback driver in engine anymore. So I have out of engine fallback drivers that control things. Yeah, you have pace and a bunch of issues, and it's 10 hertz, so I went faster than the single second loops. I think Sumo, maybe it's customizable. Still want to learn more about Sumo, but I think 1/10 of a second might not be fast enough for user interaction. It might feel laggy, so I think there's ways we can overcome that. But yeah, so this was a big decision. I don't regret it. It made it more work. I think it's going to pay off, but it certainly didn't pay off for this. It's just challenges to overcome. But I do like learning about and kind of figuring out best ways to build these distributed systems. So I enjoyed it. Let's actually end on a visualization of what it looks like now. So here's what I was able to simulate. So when I talk about this Chicago area, this is what I was trying to tackle. There's several freeways inbound, and I think this is called like the inner loop or something. In the episode, we'll talk about the regions more in depth. You see we have traffic lights. We can start to see cars on the road here. I added building data set, so you can kind of see buildings and stuff. So it adds this kind of visual context to make it nice. We have rivers and the big lake. And then let's just zoom in and see. So you see I went at pace 8. We start to see cars flowing on the roads. Zoom into an intersection. You see we actually kind of draw lines for like right-hand turn, left-hand turn, etc. Or this would be a left-hand turn. We're able to kind of record and then replay. When you're simulating, you can actually see all the messages going across the wire. So it's kind of a lot of traffic and stuff for each second. So here, this red is a congested road. Probably the stoplight is causing some congestion. There's cars getting delayed. And you actually see we have good flow into the city now. I think as this progresses, you'll see that a lot of this inner loop starts to get gridlocked. And we have a hard time congesting the major highways. They just have a lot of capacity. But anyways, more to come on this. I don't want to give away too much, but that's a little bit of all this discussion was on building. Thanks everyone for watching the behind the scenes. Let me know if you liked it. I've got a whole bunch of other ideas for some of this traffic stuff. I'm interested to see if you guys like the content. If you made it this far, please subscribe or like, and most importantly, try to comment. I really want to hear what people are thinking. So we're trying to figure out if we have the time to make this happen. We both have kind of busy lives going on. We both enjoy doing this, so we very much want to make it happen. So if you can engage with us and let us know how it's going, we really appreciate it. And gives us feedback for how we should kind of find our way through this and figure out how we can make better content for you guys all to enjoy. All right, thanks for your time, everyone. Have a good rest of the day. Bye-bye.